The balance between reactive oxygen species and antioxidants is known as oxidative stress. And that's important because oxidative stress impacts aging and then many age-related diseases, including those related to the brain, gut, cardiovascular system, diabetes, cancer, immune, and allergies. So with that in mind, can we track and minimize oxidative stress? And one way to do that is by tracking the methionine sulfoxide to methionine ratio, because as we'll see, this is an index of oxidative stress. On the left, we've got the amino acid methionine, and then in the presence of reactive oxygen species, in this case, H2O2 or hydrogen peroxide, the sulfur atom on methionine gets oxidized, as shown there, into methionine sulfoxide. In taking the ratio for methionine sulfoxide divided by methionine, that gives us an index of oxidative stress. And the importance of this ratio is that it increases during aging, which is what we'll see here. On the y-axis, we've got the methionine sulfoxide to methionine ratio, and that's plotted against age. And note that this age range goes from 45 to about 110 years old. And there we can see that the methionine sulfoxide to methionine ratio increases during aging, as both the p-value and the false discovery rate FDR are both less than the statistical significance threshold of less than 0.05. Now, the good news is this ratio can be tracked. Plasma levels of this ratio can be tracked. And to do that, I'm using at-home metabolomics with Iolo's at-home kit, which includes data for methionine and methionine sulfoxide, but also 621 other metabolites. And it's really easy to use. You can see that the tassel device on the arm, it collects blood. That's not my arm, that's a stock photo. And if you're interested in using this kit, discount link in the video's description. All right, so what's my data? That's what we'll see here, as I have 26 tests from 2023 to 2026 so far, and I'm planning on continuing to measure this for all tests going forward. When I first started tracking in 2023, the average ratio was 0.061. Over 9 tests in 2024, it then got worse to 0.068. The good news, though, is that I've been able to get it to go lower over the past 2 years, with an average of 0.048 in 2025, 8 tests, and then an average of 0.045 in 2026 so far through the first 4 tests. That raises a question of what's optimal. And although it's not yet included here, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers. It currently includes the 37 biomarkers shown here, almost 2.5 hours of video content, 62 published references. And note that these aren't the reference ranges which you can get from any LLM these days. This is what may be optimal based on how each of these biomarkers changes during aging and or associations with all-cause mortality risk. So if you're interested in that, check it out. All right, so back to our story. What's my data? And in terms of what's optimal, at a minimum, avoiding its age-related increase, which I showed earlier. And to that end, there is good news, as we can see that from where I started to where I am now, I've resisted this age-related change. For those who may not want to use metabolomics or more advanced testing, is the methionine sulfoxide to methionine ratio significantly correlated with standard clinical chemistry biomarkers? And the answer to that question is yes, as it's significantly correlated with the sum of neutrophils and monocytes. And as a quick aside, why I've combined both neutrophils and monocytes is because that they're immune cells that both increase during aging. So I would expect that their trend to be similar by grouping them together. We'll see that here with the neutrophil plus monocytes on the y-axis, plotted against the methionine sulfoxide to methionine ratio, again, as an index of oxidative stress. And then we can see over 21 tests over the past 3 years. And I should mention that 5 of these tests were not on the same day, so venipuncture versus the tassel device. Over those 21 tests, we can see that there is a significant positive correlation between this index of oxidative stress with the sum of neutrophils plus monocytes, with a correlation coefficient of 0.054 and a p-value that's less than 0.05, so this is a significant correlation. What this means is that when my index of oxidative stress has been at the higher end of my range, that's significantly correlated with higher levels of neutrophils and monocytes, which again, increase during aging. On the other hand, when this index of oxidative stress has been towards the lower end of my range or the lowest end of my range, that's significantly correlated with my lowest sum of neutrophils plus monocytes, which would be potentially good news. All right, so what about biological age? Is this index of oxidative stress related to biological age? So first, why would I think that? Well, in an earlier video, I plotted PhenoAge, the biological age calculator PhenoAge, which I have many videos on the channel, against this index of oxidative stress, the methionine sulfoxide to methionine ratio. And over 10 tests from 2023 to 2025, early 2025, we saw that there was a significant correlation between these two biomarkers. In other words, when pheno age was relatively older, which would be an older biological age, that was significantly correlated with a higher index of oxidative stress. As you can see, the correlation coefficient is a relatively strong 0.79, and the p-value was far below 0.05 at 0.006. At that time, this ratio, this index of oxidative stress, was significantly correlated with an older biological age. But we know that I have at least 21 tests on the same day for the tasso with venipuncture. Are they still significantly correlated? Is this still true? That's what we'll see here. Same setup, pheno age on the y-axis plotted against the methionine sulfoxide to methionine ratio. Again, that index of oxidative stress. And now we can see that the correlation is no longer significant, with a correlation coefficient of 0.18 and a p-value of 0.043. So after 21 tests, this index of oxidative stress is not significantly correlated with biological age. And the reason I wanted to include this data is because we can't just track once or twice. For me, and what I would recommend to others, is tracking is a lifelong thing. If the goal is to slow aging, minimize disease risk, and potentially maximize longevity, we want to collect as much data as possible. Even though 10 tests would seem like a lot in terms of the association or correlation for biological age with this index of oxidative stress, we can see that after collecting more data, that was noise. And the signal after 21 tests is more likely to be representative of the true story. But there too, I'm going to continue to test. So we'll have to see how this plays out over the next few tests. Going forward, which factors are significantly correlated with a lower methionine sulfoxide to methionine ratio? How have I been able to lower it in 2026 relative to where I started and even in that peak in 2024? How am I able to even look at correlations between anything with the methionine sulfoxide to methionine ratio? Now we're going to take a look at my approach for calculating correlations and multivariable adjusted linear regression models for diet and supplements, or really any variable with biomarkers. Since 2015, I've weighed almost all of my food, more than 99%. And I get that for some of you, that may be too much of a chore. So what I recommend is before every test is measuring as many variables inputs as possible for at least 1 week before testing. So that includes diet, fitness metrics, sleep, everything you can possibly quantify. And then I enter food data into a diet tracking app, which is Chronometer. And there are many diet tracking apps these days. I'm not here to say which is best. I've used Chronometer since 2015. If you want to use Chronometer yourself, there's a discount link in the video's description. I then take Chronometer's macro and micronutrient data and the individual food amounts, and I plot that into I enter that into a spreadsheet. So now each blood test has a corresponding average dietary intake. And as I mentioned, this doesn't just apply to diet, it can apply to any variable, including BW, which is body weight. In other words, if there are 50 days in between tests, when I take the average of that 50-day period, that then lines up with the latter blood test. And after doing that for every blood test, I can start to look at correlations, especially after 3 tests. Technically, after 2 tests, you can do a 2-sample t-test and compare 30 or 50 days before test 1 and 30 or however many days before test number 2, and then just use a simple 2-sample t-test to see what may have been different for those 2 periods to gain insight into what may move the biomarker needle. Once we get to 3 tests, we can start to look at correlations. And granted, there's a lot of noise in the early data, but it's always test, evaluate the data, the correlations, try a new intervention, and then repeat. And after doing that test over test over test, we can start to try to discover the recipe that may help move biomarkers in the right direction relative to the wrong direction, both in terms of aging and minimizing disease risk, and potentially as a strategy for optimizing longevity. When using that approach, strawberries are the top food for its correlation with a lower methionine sulfoxide to methionine ratio, which is what we'll see here. So on the y-axis now, we've got the methionine sulfoxide to methionine ratio, and that's plotted against average daily strawberry intake in grams per day. And then we can see that there's a significant inverse correlation with that correlation coefficient of negative 0.48 and a p-value that's lower than the significance threshold of less than 0.05. So what this suggests is that when my strawberry intake has been at its highest, that's been significantly correlated with lower oxidative stress based on this ratio. And when my strawberry intake has been at its lowest, that's been significantly correlated with the higher index of oxidative stress. Now, I should mention that if you look at how many grams of strawberries that I was eating, some of these tests have a lot, 900 and around 1,200 grams. And all the data, these data, would suggest that may be optimal. And again, I know it's correlation does not equal causation. I am at no point suggesting this is causation. But this may be too high, too high of an intake of strawberries for reasons I won't go into in this video. More recently, for the next test, I'm averaging about 600 grams of strawberries per day, frozen strawberries, organic. But note that calorie intake is also significantly correlated with a lower methionine sulfoxide to methionine ratio. And if you want to see those data and correlations for all diet or other inputs with biomarkers, not just metabolomics or metabolites from metabolomics, but all of the other standard clinical chemistry biomarkers, even HRV and resting heart rate, everything. I have a correlation specific tier on Patreon, so if you're interested in that, check it out. After seeing the data that calorie intake is also significantly correlated with this index of oxidative stress, the next question becomes, are strawberries associated with this index of oxidative stress after adjusting for calorie intake? Now we're going to take a look at calorie-adjusted associations with the methionine sulfoxide to methionine ratio, as shown here. What we're looking at is the beta coefficient. If the beta coefficient is positive, that means that higher intake of the food or nutrient is associated with a higher index of oxidative stress. Or if the beta coefficient is negative, that means that higher intake of the food or nutrient is inversely or associated with lower index of oxidative stress. And then for the p-value, we've got that as the measure of statistical significance, less than 0.05 as the threshold. And I guess some of you are going to say I should be using the false discovery rate. I've used that in previous studies, PubMed studies that I've published. I'm not opposed to it, but it can exclude potentially meaningful correlations or associations. And rather than trying to prove a point statistically, as we'll see in a minute, I can actually test the correlations or associations by increasing or decreasing a given food, which to me is a better approach than using FDR to try to prove a point statistically. When looking at this table, we can see that two foods or nutrients are now significantly associated with this index of oxidative stress after adjusting for calorie intake: watermelon and total fructose. It shouldn't be a surprise that total fructose, which is found in watermelon and strawberries, would be inversely associated with this oxidative stress index, as watermelon and strawberries contain fructose. But what this data suggests is that when my watermelon intake is at a relatively high level, regardless of calorie intake or after accounting for calorie intake, that may lead to a lower index of oxidative stress or a lower oxidative stress ratio. What about strawberries? What happened to strawberries, which were significantly correlated by themselves with a lower oxidative stress ratio? What happened after accounting for calorie intake? Now we can see that their p-value is outside of statistical significance at 0.14, and although its beta coefficient is inverse, which would suggest that a higher intake of strawberries would be associated with a lower index of oxidative stress after accounting for calorie intake, it's not statistically significant as its p-value is greater than 0.05. All right, so what do I do with this information? For the next test, which will be sometime around mid to late-ish September, to try to keep this ratio low, the methionine sulfoxide to methionine ratio low, I'm aiming lower for calorie intake relative to the previous test and higher for watermelon. Note that this approach, I'm not just trying to improve one biomarker and mess up a whole bunch of other stuff, which then raises the question of, if I can move the needle with this oxidative stress ratio by altering calorie intake and watermelon intake, what potential effect will that have on other biomarkers? Watermelon has a net 3 correlative score, positive 3 correlative score, with 30 standard clinical chemistry biomarkers. And on the other hand, calorie intake has a net negative 7 score with those same 30 biomarkers. So what that suggests is that if I go higher for watermelon, that may move the needle in a positive direction for more biomarkers than not. And if I reduce calorie intake, similarly, that may also move the needle for more biomarkers moving in the right direction relative to not. Conversely, if I increase calorie intake, based on this net correlative score of -7, we'd expect more biomarkers to move in the wrong direction relative to the right. So when changing calorie intake or lowering calorie intake and slightly or increasing watermelon, potentially, based on these data, I may be able to lower this oxidative stress ratio while not negatively impacting the majority of these other standard clinical chemistry biomarkers. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I offer blood test consults and also post at least twice per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtests.com, which is where I get the majority of my non-metabolomic tests done, Life Extension, which has a bunch of tests that are not included on ultralabtests.com's website, At-Home Metabolomics, as we saw in this video, NED testing with Gfinity, which I've tested more than 30 times, epigenetic testing with True Diagnostic, at-home blood testing with SciFox Health, which includes the best epigenetic clock of epigenetic clocks, Scrimage, oral microbiome composition, I now have 20 tests, diet tracking with Chronometer, green tea, the clearly filtered water filter, which I'm using both of those every day, the green tea and the clearly filtered water filter. Or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got new merch, including the Health and Longevity Optimizer as shown here. We've got Data is my North Star, Figuring Stuff Out is my drug, or the ConquerAging or Dietary logo. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.